So what is Wi-Fi and how does it actually work? Wi-Fi is a type of electromagnetic radiation, part of the gang that includes visible light, radio waves, X-rays and gamma rays. So the different types of electromagnetic radiation are pretty similar, but what makes them different is the length of their waves, their wavelength. Radio waves are long, like this. Short waves like X-rays look like this, visible light is like this, and Wi-Fi is like this. Wi-Fi's wavelength is about 12 centimeters, and it bounces around too little for us to see. But if it was visible, this is what it would look like. Your router emits pulses of signal in a dome 20 to 30 meters across. And this is just one Wi-Fi signal. If we could see all the Wi-Fi in a city, it would look like a massive field of big-top circus tents.
As explained in the previous brief presentation, wireless transmission uses electromagnetic waves to carry information. And, as explained, those magnetic waves have different wavelengths, and hence, different frequencies. Frequency is a measurement of how many waves are passing by in any given second. Imagine yourself standing on a beach when the water is very calm. The waves tend to drift onto the beach as small, more frequent waves. However, after a heavy storm the waves are more likely to be more powerful and more widely spaced. Electromagnetic waves are measured in gigahertz. A gigahertz is 1,000 million waves per second. So a 2.4 GHz wireless signal has 2.4 thousand million waves passing per second. A 5 GHz wireless signal has 5,000 million waves passing per second.
The standard for our wireless networks is 802.11, and it's a standard that is created and maintained by the IEEE LAN MAN Standards Committee, which is the 802 committee. They have many updates to this standard over time. So here's a summary of these 5 802.11 standards. 802.11n was released in October of 2009, and this update to the 802.11 standard was designed to bring together and upgrade 802.11g, 802.11b, and 802.11a networks. You can have 802.11n operate at 2.4 gigahertz and optionally 5 gigahertz simultaneously. 802.11n has a maximum theoretical throughput of 600 megabits per second, a significant increase over the previous standards because 802.11n is using something called multiple input, multiple output, and is using multiple streams to be able to have this kind of high throughput. 802.11b is 2.4 gigahertz, again one stream at 11 megabits per second, and 802.11g was 2.4 gigahertz, again one stream at 54 megabits per second. 802.11n, you could choose between 5 gigahertz and or 2.4 gigahertz. There were 4 maximum allowable streams occurring with multiple input and multiple output, and at 150 megabits per stream, you have a maximum theoretical throughput of 600 megabits on 802.11n.
Within the 2.4 gigahertz range, the most popular wireless band, there are a varying number of channels. The United States has 11 Wi-Fi channels, and European countries have up to 13 Wi-Fi channels. The 2.4 gigahertz band is where your computers and other devices access the internet via 802.11b, G, or N wireless networks. If your wireless card supports dual band scanning, we strongly recommend investigating the 5 gigahertz band. The 5 gigahertz is where you'll find newer and faster 802.11a, N, and the new 802.11ac access points. The 5 GHz Wi-Fi band will have less range but greater potential for higher wireless speeds and in general has less consumption than the 2.4 GHz band. At MetaGeek, we call the 2.4 GHz the wild, wild west of wireless. Anyone can use the 2.4 GHz band, which means anything goes, and not everyone thinks twice before they shoot.
So how come I can sometimes get great signal 2 floors up, but none in the room next door? Well, as Wi-Fi travels out from its source, it's affected by the objects it encounters, be that concrete, wood, or other Wi-Fi. Also, if there are a lot of Wi-Fi signals near you, parts of your signal could be delayed by them bumping into those, making your pages load in a more jittery way. Interestingly, you can actually buy Wi-Fi paint, which blocks other signals from interfering with your Wi-Fi signal.